Dr. Yan, how are you doing? Sorry about
I'm
that.
fine. Yeah.
All right. Can you share your screen, please?
I'll try. Yes. I need to be allowed to share.
Yes, I've given you permission.
Okay. Let me try. Oh, good. Now I can.
All right. So we're glad to have here with us Dr. Wei Yan. Dr. Wei Yan is the director of the PhD and MSc research programs in the Department of Architecture, and also a Southland Page Endowed Professor at the University of Texas A&M University, with expertise in computational methods in architecture, augmented reality, building information modeling, parametric modeling, simulation, and optimization. He has led research projects funded by the National Science Foundation, National Endowment for the Humanities, Autodesk, and co-led NSF, DOE, ASHRE, and so much projects. He has received the Best Prize, Paper Prize in Design, Computing, and Cognition in 2006, and the Best Paper Award in Conference on Learning and Collaboration Technologies in 2022. He was named a Presidential Impact Fellow in 2017 and a recipient of the Student Government Association Open Educator Award in 2019, both at Texas A&M. Yan was educated at the University of California, Berkeley, PhD in Architecture, MSc in Computer Science, Swiss Federal Institute of Technology, Zurich, and currently, in 2012, he was a guest scientist at Lawrence Berkeley National Laboratory and a visiting professor at Stanford University. In 2007, he received NEH Digital Humanities Startup Grant. Thank you very much, Dr. Yan. It's a pleasure to have you here. Now you can share your screen and the floor is yours. Thank you.
That's great. Thank you so much for the invitation. Hello, everyone. My name is Wei Yan. I'm a professor of architecture at Texas A&M University. Today, my topic is mixed reality and AI for building design and construction towards sustainability. Buildings are responsible for 40% of total energy use in the United States. And it's also responsible for all electricity use. Like the percentage of that is also extremely high, which is 75%. And then for the nation's carbon emissions, 35%. Building modeling, simulation, optimization, and visualization are methods to enhance building design towards energy efficiency and sustainability. For example, building information modeling was applied to the building design in the Memorial Student Center at Texas A&M University. And the building information model, which we call BIM, was created by the architecture firm Perkins and Will. Design leads to the construction of the building on campus. So this is the photo of the building on campus. However, the building design model is highly complex. As an example, cross-section views in the model are major design documents, but they are very difficult for designers and students to understand and create. For instance, here is a question: which of the answers on the right is correct? That is corresponding to the actual 3D view of the wall on the left. So this is a hard question for most students, and the students also have to create the section view in order to represent their design. So it can be much complex than this in the real world project. This is actually a relatively simple example. But by superimposing building information models on the physical building, augmented reality has broad applications in design, construction, and education. So these are two photos of the same building I showed earlier, which are the MSc buildings on campus. But on these two photos, we can see the red and the green wire models or wire models, which are the CAD models and the building information models. So in this case, the CAD model were converted from the building information model. So the model can be shown on top of the physical model. And you can see the alignment of the virtual model on the physical model is very accurate. So this allows us to present the building information on top of the physical model or the physical building in this case. And this is one of our augmented reality projects for visualizing building design and construction in the physical environment. So in this case, our former PhD student, now Dr. Ashur, utilized an iPad with an augmented reality tool that he developed to superimpose the building information model of this building, and he could walk through this building and see the alignment between the virtual model with the physical building or the physical space. So on this image, the green wireframe is the virtual model or the building information model that we can see on the iPad. On the left side, for example, the iPad sees the green model, although in the reality, there isn't the model in the physical space. So I want to show this video that can demonstrate the augmented reality technology and the accuracy of the so-called registration or alignment between the virtual model and the physical space. So again, in this demo, the green wireframe model is the virtual model, which was made based on the building information model containing the geometry information as well as non-geometry information. For example, the materials, the schedule, the function. On the lower right side, we can see the selected building component information. There are different parameters and their values can be displayed. So in this experiment, we can also utilize cross-section to virtually cut the physical walls in order to showcase the sections or the different material layers of the walls. So this is like X-ray mode. And then whenever we select a building element, the information will show. So we utilize this to help students understand the building information models as well as the physical construction, so that they can design better buildings in the future based on their better understanding of architecture. Furthermore, building energy simulation can be conducted and visualized in beam-based augmented reality. And this is another project using our PhD student room as an example. So here we see a photo of the PhD student room, and on the right side is the floor plan of the room. And in order to accurately build the virtual model or the building information model, we also utilize the 3D scanning, which actually scanned more areas in the building. But the focus is going to be the PhD student room. And here again is the PhD student room, but the virtual model is superimposed on the physical room. So in this case, the yellow wireframe model is the virtual model. And that is built based on the 3D scanning, as well as students' manual work to create the building information model. And with this augmented reality application, we can have different visualization modes. So we can turn on different components or even conduct simulation and visualization of thermal energy in this environment. So the students can learn how energy flow works in this physical environment by entering this augmented reality scene and see different types of visualizations. For example, in this case, the thermal properties and the temperature information are attached to the physical wall and the window. The wall and window are on the right side, but the information are attached with them or aligned with them accurately. So when the students walk inside this room, they can actually see the visualize the information. Otherwise, the information is hidden in the physical environment. So augmented reality can allow hidden information to be reviewed in the physical space. And the air temperature values are visualized in a voxel representation in the physical space. So there are different boxes, and they represent the different temperatures of the air in the room. And this is still image, but we have the animation that can demonstrate how this works. We have our demonstration available online in YouTube. So for any audience who are interested in learning more about this project, we will be able to share the presentations later on. And from existing building information to building energy modeling, various approaches are available. For example, photogrammetry, using photos of a building to reconstruct the building model and then convert it into a building energy model. The conversion is challenging because the semantics of the building geometry needs to be created. Now, this is an example showing in the photos and the images, as well as the table, how we start from physical building and get to the 3D photogrammetry of the building, and then convert it into energy model. Then we can use Energy Plus to simulate the energy consumption of this building. And then we developed a machine learning method that can help recognize building components for reconstructing building information models and building energy models. Recognizing building objects is the foundation of automating 3D building reconstruction for applications such as building energy modeling, building information modeling, and urban modeling. Machine learning can help in this process, and we developed our project to utilize machine learning in order to help enhance the whole process. And this process leads to the application that we developed, which can automatically generate a large amount of data that can be used for training machine learning. And this is example. So we have on the top 3 different floor plan as an input to our developed application, and then the result can be displayed on the bottom. So we can have many new buildings generated automatically based on our input. Either they are the floor plans or different parameter values. For example, here we have the algorithm to get input from the building envelope. The distance of the columns, for example, is a parameter. So we developed this application that can generate many designs automatically, and utilize these designs. We can create data for training our model in order to predict or recognize the building components in the physical world. So this is our parametric model generation. So you can see by changing parameters on the left side, on the right side, we can generate many different buildings very quickly. So the buildings on the right side changes according to the parameters. And these are building information models also, so they contain geometry and semantic informations. So we have utilized the system to generate more than 600,000 image pairs for machine learning training. So here on the left side, we have the generated model, and then on the right side, we have the images with the labels of the building components. And we can utilize this to train our machine learning model in order to create the building information model and then energy models. Furthermore, we utilized generative AI to create the building information models. So here is a final example of using ChatGPT to generate a building information model. Although it's a simple, it can be shown on the right side, but it is a model that is generated in widely used Autodesk Revit building information modeling tool. So our goal is to utilize AI to automate the process of creating building information models and energy models. So in the future, the design workflow can be enhanced towards designing and constructing more sustainable buildings. We appreciate our PhD researchers in our group and the support from National Science Foundation. Thank you so much. Please let me know if you have any questions.
Thank you very much. You can please, okay, perfect. That was a very robust presentation. I have one question for you. The question for you is how does this technology impact the life cycle management of building projects from design to demolition?
Yeah, so we have already demonstrated the design phase use of the technologies, but in the life cycle, other phases of the building life cycle, we can also utilize technology. For example, augmented reality can be used in building facility management. For example, building facility manager can utilize mixed reality headset to inspect the building components, or HVAC system, for example, can help review problems and help repair, help manage the whole system, because it can help, augmented reality can help review the invisible information or to see through the building elements. It's like see through the walls, for example, see into the walls or see into the machines. So this will help significantly the process of this facility management. And in the construction process, we have projects to utilize augmented reality to guide the assembly or construction process, like brick by brick, step by step. So that is another significant use of augmented reality. And then in each phase, AI is or has been studied of its application. And in the future, we expect, based on the current quick advancement of AI, AI applications can be applied to more stages or be used more effectively in different phases of the building life cycle.
Thank you very much for the wonderful presentation. We really enjoyed the presentation. So it's very new. Using the AI in mixed reality of technology is very innovative. Thank you so much for honoring our invitation today. Today we're
Thank you so much.
You're welcome. So now.